I'm Anil Kumar, and in this video we will learn how to write primary trigonometric ratios for a given right triangle. So the question is, determine the exact value of primary trigonometric ratios of both acute angles for the given triangle. So here we have triangle ABC, which is a right triangle. One of the sides, the smaller side of 1 and hypotenuse of 2 is given to us, and we need to find exact value of both acute angles. It really means that what we need to find is, these are the two acute angles for us. Primary trigonometric ratios are sine of an angle, cosine of an angle, and tangent of an angle, right? So what we need to find is sine of A is equals to what, cosine of A equals to what, and tan of A equals to what. And we also need to find sine, cosine, and tan of angle B. These are the two acute angles in this particular triangle, correct? So we have to find what is sine of B, what is cosine of B, and what is tan of B. Remember, we have to find the exact values. Now to find sine, cosine, and tan, we also need to find the value of x. How do we get the exact value of x? For that, we can use Pythagorean theorem, correct? Now, sum of squares of smaller sides is equals to the square of the hypotenuse, right? So we know using Pythagorean theorem, let me write down here, we'll find x, right? So which says that x square plus 1 square is equal to 2 square. That is to say that x square equals to 2 square is 4, 1 square is 1. Take away 1 and that gives us a value of 3. X square is 3, that means x is equals to square root of 3. So I'll recommend do not use calculator. It might give you decimal answers, right? Since we are trying to find the exact value, you have to write square root 3, right? So we can say x we have calculated as square root 3. So we can use this value of square root 3 and then find all exact values of our primary trigonometric ratios. I hope now it's absolutely clear. You can pause the video, write down your answer, and then check with mine. Now what is sine? Well, we also remember SOHCAHTOA, right? Sine is opposite over hypotenuse. Let me write down that also. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent, right? So we'll make use of this also and fill it up. So sine of A, if you see from A point of view, opposite is 1 and hypotenuse is 2. So sine of A is 1 over 2. Cos of A. Cos of A, adjacent is side between angle and right triangle. So it is square root 3. Hypotenuse is 2, correct? For tan, opposite is 1, adjacent is square root of 3. So it is 1 over square root 3. Now let's do it for the angle B. From angle B, opposite side is square root 3, right? So sine B is square root 3 over hypotenuse of 2. For cosine, adjacent side is BC, which is 1. So cos of B is half. And tan, opposite side is square root 3 over 1. So it could be written as square root 3. So that is how you get exact values of sine, cosine, and tangent for the given acute angles. Now as an exercise, what you can do is, you can use inverse of these and find angle A and B, correct? So, for example, what is angle A? Angle A, you could write sine inverse of half, right? Sine inverse of half. Use calculator, find it out. What is angle B? So angle B will be equal to sine inverse of square root 3 over 2. Or once you get angle A, you can do 90 minus angle A to get angle B, right? So that is how you can get your angles, correct? So if you use your calculator, let me use it and show you how you get the angles also. Sine inverse is the second function, sine within bracket 1 divided by 2, right? 1 divided by 2, and you get your answer, which is 30 degrees. So that gives you 30 degrees. And if you do the other one, you'll get 60 degrees. You could also use cos inverse of half, right? So we can write down this is 30 degrees for us, and that is 60 degrees. That is an extension to our question. And now with this, you also understand how to use inverse of our trigonometric ratios to find the angle. I hope that helps. Thank you.